So this is the technology, and now I will give the floor to my colleagues who will talk about the other aspects of this project. So we start with Hasan from University of Siegen, and he will talk a bit more about the recommendation technology, which is based on knowledge graphs. So I think we need another microphone for so long. Here is the clicker and bring you the mic. Thanks.
This is now on, and yeah, indeed. Maybe if we can have the slides again also shared. Like Gabor mentioned, what we were thinking based on the eDoer system is how to enhance also the data structure that we have, which was created by the experts themselves through the recommendations in the content curation side. And indeed, for this, what we wanted is to build a recommendation system for learners, to provide learning paths based on a network that is created from the educational content by the experts themselves. And therefore, I would go a bit to the knowledge graph itself, describing this network and how it was created, and then go to the recommendation algorithm based on it. So Oscar knowledge graph, what is Oscar knowledge graph? The idea of the knowledge graph is to create a network of interconnected entities, which is in our case, the educational materials that was created by the experts. This network is meant to enhance the connectivity between learning materials that are relevant to each other or similar to each other. And so for our journeys, as has been mentioned before, we have a taxonomy. And the taxonomy starts with the journey itself. And that journey includes several courses. Each course has multiple topics, and the topic itself will have multiple educational packages that are groups of educational materials like videos or web pages. And the educational package includes then the actual material that one studies. This would be the taxonomy that is followed in eDoer, robustly and simply enough to describe the materials that experts are creating. Now, to take an example from the journeys that our experts in Oscar have created, we have three main journeys: career development, research and mental health, and the transferable skills program. All of these journeys follow the same taxonomy. And you can see that some of those journeys actually share some materials already. So they are already connected. And this is thankfully due the visibility of educational materials that exist in the system through the content curation side. However, not all the journeys are connected to each other. And therefore, our goal is to create additional connections that might relate journeys that have been separated to the existing journeys and other journeys that other experts have created. If we make this graph now look a little bit nicer, we end up with a network of the educational materials that have been created from multiple experts who they might not be connected to each other. They might not have seen what materials other experts have created, and so on. Now, through this network, not only we enhance the connectivity of educational materials that have been created by experts, but we can conclude, like you can see in the densely connected area, some of the skills, the topics or the courses that are densely connected to each other. They have relevancies or similarities to each other. And those happen in the same context. This similarity reflects that all these skills somehow are taught in similar contexts. So we can then, through the graph, contextualize the educational learning recommendation. And that's what we went ahead trying to do, and utilize this data structure, which is now densely connected, to create a recommendation system. And because we have a network, we create a learning path recommendation. So for the recommender system, to get the idea very simply, this is a simplified version of the knowledge graph that we have. And you can see that our user has a certain context with courses and topics that they have learned formally or through the system. And they are connected, or they are targeting a final learning goal in the upper right corner, as you can see. And there is a multitude of paths that they can follow to reach that goal. The question is how to find a suitable path for the user and for their corresponding context. And what we do is to implement here, without going too much deep into the technicalities, a light version of a Markov decision process, which is a reinforcement learning algorithm or implementation of reinforcement learning, which works as follows. You need to create your path, or to find what is the best way to navigate through the courses towards the goal. At each step, we have to make a decision. Which action should the learner take to reach that goal in the best way? And the best way reflect here what is suitable for the learner context. So the decision now to define which of those paths is more suitable for the learner. And to do this, we actually investigate all the potential paths that exist in the network. As simple as that. We set a virtual learner, a virtual version of the student or the learner, to actually navigate through all the possibilities that exist within all these paths between the learner and the learning goal. And they give ranks or weights to each action, to each step. So for example, here, this step gets a higher weight, and then the learner gives that more importance. This weight comes from the algorithm that matches the action that is taken with the user context itself. And so we move to the next step, and we here have only one decision. The next step has also, again, 3 decisions. The learner investigates all of them, gives weights to each of the possible actions, and then ends up with a final path that reaches the final goal. So this is, in general, how we explore the whole network, and we try to give weights to all the potential paths. And at the end, the highest weight or highest weighted path will be recommended to the learner. We did several rounds of evaluation for the system, quantitatively and qualitatively. So we talk about connecting educational materials, which means we need to evaluate the way we connect those materials to each other. And we use actually text mining to analyze the textual content of the educational materials that exist in the system and find similarities, semantic similarities between those educational materials. And so we started by evaluating those semantic similarities, comparing what the algorithm had found to the connections that the experts themselves have created in the system, connecting journeys to courses, courses to topics, and so on. We also evaluated the graph structure itself. And here, I go back to what Gabor mentioned about the didactics and the pedagogy that is essential behind generating valid data structures and valid recommendations. So we tried to use some of the graph metrics, like the connectivity degree between the different elements, the communities that are created as contexts in the graph, and so on and so forth. And we tried to interpret them pedagogically. What would be then the meaning for an increased connectivity in the network in terms of the learning process? And we found that those measures have been positively increasing or decreasing depending on what pedagogy would actually prefer. We also went to the experts themselves, because without experts, we can never evaluate our system in the correct way. And so we ran several focus groups with experts who created the materials, experts who did not create the materials, and also with learners. And from those focus groups, we actually got feedback about how the system works in general. And we got, most importantly, important lessons that we learned from each of those focus groups. I will go at the last step to those lessons that we have learned from our evaluations and from the experts that we have worked with. One of the first lessons that we have learned is that learning happens in a context. And there are actually several learning theories that address that context very explicitly and address how important it is for the learning to take into the learning recommendation to take into account that learning context. We also learned that skills come usually in sets if they are to be useful to a certain use case or a certain problem that a person is facing in their work, in their academia, and so on. So it's not an individual skill that we need to recommend, but this learning path, which is a combination of skills ordered in a certain way, selected in a certain way based on a certain logic, so that they can provide a combination or a set of skills that a person can actually utilize in their own context, in their own problem or their own environment. One example would be, for example, communication skills, which are considered transferable skills that can be used with researchers to solve their problem, for example, communicating with their supervisors or their peers. And it can be used in another setting completely in a different way to enhance communication on a lingual level, for example, for expanding networking, for enhancing networking. The two use cases are different, two contexts, and so the same skill is recommended with a different set of skills, different combination of skills, so that it is actually useful. And the last lesson, which is actually one of the most important lessons that we have learned, is that learners have different ways in defining their goals. Some learners know how to name the goal they are looking for. I need to learn communication in academic environment. Some learners actually describe a problem they are facing, and they might conclude what the goal that they need is, or they might ask for help. Some learners have actually no clue. They think they are looking for this goal and this is what they need. And when they talk to experts in a mentoring session, they find out that they are actually targeting something else. And so here, the way that the learners are actually setting their goals is very much essential. And it is as essential as the context of the learner itself, themselves, or the context itself, and as the skills that are being recommended, the recommendation algorithm that's working, the data structure. So working on this step of setting the goal in a correct way and supporting the learners with ways to actually search, describe, and find or discover the learning goal that is suitable for them, what they are looking for, is essential. And here I go back to the system, what Gabor has shown, in actually providing more visibility of educational materials or journeys as learning goals that the user can actually select from. But without an expert, that will be still a big problem. And therefore, the system offers the mentoring, which my colleagues are going to explain in detail, which is then promoting this collaboration between the human and the machine. We know that no recommendation would work without an expert, and the best recommendation comes from the human. Now, to support this human with a recommendation system is not meant to replace the expert in recommending, but to help the user in getting this set of skills, this learning path, setting their goal in the best way. And when that is challenged, then we have the mentors available at all times through eDoer system to provide this support. And with this, I move to our colleagues, and thank you very much for your attention.
Thank you. Please.